中国来参加预聚会，指望感染中国人。留言嘛，但是说的有鼻子有眼。等一下我得开会了。
Hi, Joel.
Hi, Tor. Hi, James Brown. So we are waiting for Lucas. Yeah. So so James and Bowen and Tor, you're welcome too. That after this meeting, Sunil wants to do a virtual drinking, and he will join the same meeting room, which means everybody drink a beer and you know, pretend we're in the same office.
That sounds really cool. Although it's I unfortunately have another meeting at 11. And
I was thinking so, drinking in the morning is probably not very good for you, but yeah.
I mean, I do have alcohol-free beer in the fridge, you know. So
yeah. Okay. So
I'm prepared for those scenarios.
Okay. Yeah, always be prepared. Lucas, you are there?
Yeah, I'm here.
Okay.
So just unmuting anything.
Yeah. Okay. So I'm going to explain how I think we will make secret sharing work. And here is a chart that I will wish to share with you guys. Share mode. How do I share stuff? Yeah. So can you see my screen? Is sharing working?
Yes.
Actually, it's
yes.
Yeah, now we go.
Now everybody got it. Okay, good. So this is basically the steps for sharing and recovering. I'm going to go through the simplest scenario, which is using SMS and email as the second factor, and then I will go through the scenario where the password the secret question is used as a second factor. Then I will go through the process of Google authentication used as a second factor. And there are different implications. So the first one is the one that I verified with Tor that I believe already work, but let me walk you through the process. So step one, user enters a password, and this password is going to be distributed to every every one of these three parties who are going to do secret sharing later. And there are protocols to use, and Tor is going to investigate what software package or protocol can we adopt for this purpose. So there's the reason for some cryptographic protocol being involved here is that we cannot share the password directly to the three parties, because then each one can fake the user's identity to enter the recovery as the other person, as the other user. So the idea is that even if the hacker takes one of the three parties down and take total ownership of the server, he's not able to restart the recovery process by pretending having the password. And the second step is that user enters a second factor, in this case email and SMS. So we will Alpha Wallet will set up a server. The Alpha Wallet is not one of the three parties. Alpha Wallet will verify that the user owned email address or mobile phone by validating a one-time code, and then copy the email address and telephone number to three parties. Now, the second factor, if one of these parties are taken over by a hacker, they will not be able to they will not be able to, as I explained, they are not able to use the password to start the recovery process. But even if they have, they are not able to do the second factor because that would require code being sent to the user's mobile phone. And you can see here in the validation process, no matter it doesn't matter if the user chooses a mobile phone or email, the user has to answer 3 codes from 3 parties. That's intended so that each party has to work by themselves. And the third step is the traditional shared secret sharing process, where the user decrypt the private key, which is typically stored in the encrypted format in the mobile phone, and then enter the secret sharing protocol, and each party will have a share of the secret. So this is the setup process and the recovery process. Now, normally these three parties will do some other protocols like refreshing the key, which is not covered here. Now, the recovery protocol, the first step is that the user provide a password and enter a distributed password verification protocol. The intention is for all three parties to recognize the user as the same person as the one who previously backed up the key. And then the second step is that three parties independently send the code to the user, and so that if the user has chosen the poor password, he can still have a little bit of protection. And the third stage is that the three parties have all authenticated against the user. No, this is the same guy who showed up earlier, and start a password recovery protocol. Basically, this is how it works in the simplest case, where the second factor is the SMS or email address. So I think I already talked about this with Tor, but now I'm sharing this with everybody. So does it make sense so far? Do you have any questions? Then I will make the situation more complicated. But for now, is it all right?
Just one quick note. So for the recovery aspect, step number 2, you mentioned 3 codes. Where are the codes coming from in a user perspective? Is this something that's being sent to an email 3 times, or is it like 1 email, or does he have
3
to
emails.
set up? Okay.
3 emails or 3 SMS. These 3 are sent by 3 parties.
They're sent from each of the servers holding a share of the user's private key. Basically, this is to avoid the fact. So let's say the user has not practiced good password hygiene, and has used a low entropy password, like password. And one of the servers is evil, and it wants to learn the user's Ethereum key. So then it just pretends to be the user towards the other 2 honest servers, since it already knows its password. But that's not going to be enough, because it needs to have the second factor. If there's only one second factor, it becomes way more easy, because if there's a second factor all servers agree on, then that evil server will necessarily also know that and be able to impersonate the user. So that's why it's necessary to protect against this case, that each of the servers themselves pick a second factor that the user must return to them, that the other servers don't know, to protect against the fact that the servers might be evil.
Okay. Yeah, that makes sense. I mean, I guess also what I'm asking here is, so what does the user have to give to get that? So on the left side, so it's still the same passwords and email, and or does he have to give, for example, 3 passwords or 3 emails? Is the condition still password and email, or is there more steps to do? I guess that's all I'm asking here.
It's just 1 password, 1 email.
Gotcha. Okay.
I mean, at least that's
yes.
the nice solution. You could also, of course, you could do it using a boilerplate approach with 3 different passwords for each of the servers, but we all know how that's going to go, right?
Yeah. So also, if the user chose mobile phone, that's 1 password, 1 mobile phone number.
1 password, 1 mobile phone number. Okay. Yeah, that's then.
Okay.
The important aspect of this is just that it's each of the servers that pick the second pick a second factor for themselves.
Okay. Yeah, that makes sense. So in perspective, it's okay.
And any technical questions? I guess that's no, because if James and Boone has a question, usually they just jump in. So
I'm guessing that there's some kind of algorithm that we can use to combine these codes to produce the key.
Oh, so the algorithm, I forgot to mention, every time when you see this circle, it means some magic algorithm is being used.
Okay, all right, cool. I see. Yeah, okay. So from on the last step, you're essentially using the the feedback from those three inputs through the algorithm, and then that recombines into a private key.
Yes, and
How about or a
I change the
seed?
direction. Yeah, now it's
I
clear.
presume it'll be stored as a seed rather than a raw private key.
Oh, it's going to be a raw private key. It doesn't make sense it doesn't add protection by converting to a seed.
Okay. Okay. Yeah, that's fine. So basically, if somebody chooses to use this method of protection, then they're not going to be using a seed.
They can if they want to.
Oh yeah. Okay, you can output a seed. You can output a private
not
key
part of this
from a
story.
seed. Yeah, got it. Okay.
Okay.
But they won't be able to get the seed back. Like if they recover using this method,
No,
then they'll get
they
a
will
raw
not.
private key.
They will not get the seed back. If they want to do this again, it's their choice.
Yeah. Okay. That's cool. Yeah. They won't lose their money. Okay.
Okay.
That makes sense.
So far so good. I can continue.
One question.
Yeah.
I think I missed the previous session where we talked about this. So probably a very stupid question. So is the point that the user just needs to remember a password, remember the phone number or an email, and then
the user needs to this is the funny bit. The user needs to remember their Ethereum address and the password.
Okay. As well as either the phone number or the email address which they use.
Yes.
And then they will be able to recover their Ethereum key, private key or seed, basically, right?
Yes.
Is there a chance that they use their email password for this?
We can start an alternative recovery protocol where the user starts with the email and or SMS. Yeah, actually, this should be the correct recovery protocol. But that has the problem that, okay, so this is the modified protocol to solve your problem where the user might have forgotten their Ethereum address is actually more complicated. There's a first step where the user enter the mobile phone number or the email address, and then the user have to enter the password, and then the authentication code is sent. So effectively, step 2 has to be broken into 2 steps. One is user enter the email address and the SMS, and then this is sent to each individual node in place of the Ethereum address, and then we start from protocol 1. Yeah. So thank you for reminding that. So yeah, there should be a more elaborate recovery process, but the setup is the same.
Oh no, actually my question was, is it possible that when the user set this up, they decide to use the email password as the password in step 1? It's easy, right? Because I need to enter an email address and I need to enter a password.
Yes, they would. A lot of people will do that. It's not. It's whether or not how weak is that depends on the algorithm chosen here, and that's Todd's topic.
Maybe those people deserve to lose their money.
So yes, but
I mean,
some users are really dumb.
If they use the same password as their email, we're basically removing the advantage of the second factor.
Yes.
And yes,
under the assumption that the user's email provider is not, going to be evil or get compromised. I mean, that there's always going to be some sort of, there's always going to be a dependency on links and things like that in a situation like this. So I mean, we can't really do anything about that if the user uses uses the same password.
Unless we use like a suffix or something. So basically, when they submit their password, we put a suffix on it, and then we reproduce that suffix on the way back. And then the hash won't match up with the email password hash.
Yes, that's correct. That can be like that's a good idea. That can
kind of like
can
a
help a
salt.
bit. Of course, it doesn't prevent if it's if you know this, like if you know that
Yeah, for sure.
that this
Yeah,
is the
that's
case.
true. Yeah, yeah. It's kind of
But
like
it makes
security by obfuscation.
yeah. But it makes it less trivial. It's like hardening, right?
Yeah, a little bit.
Can I provide a side note to Boone? In this protocol, none of the three parties have the password of the user, nor the hash of the password of the user.
Yes.
So, the three parties is not able to determine the password of the user, although those who already compromised the user's email address password through means outside of this network is able to use that to recover the key.
Yes, that's what I'm talking about.
Yeah.
But yes, it makes sense. We can't protect very, very dumb users.
But we can provide the following scenario where one of the three parties wishes to use this to fake 2FA and get the user's password, or that a hacker compromise one of the three servers and use that to recover the password, recover the private key.
Yes, I understand that.
Yeah.
Yes.
Okay, so can I go on?
Yeah, of course, here the issue is if the user forgets his password, then there's nothing to be done.
Yeah, I'm just gonna add some notes here, by the way, everyone. I do try to design that according to what I call protecting the user against himself. And the idea is that we ask him the password first, and I think it would be an interesting idea for him to reinforce that it needs to be a unique password. Email is asked later, so he might not exactly associate the same password with the same email, so he's primed with a password first. Regarding the forgetting of the password, at this stage, we're forcing him to write, I understand that he needs to remember. And more than that, I mean, yes, most of the interviews, what they say from non-security minded users, they will do that. They will just use the same password. And I mean, another option that I was considering a few days ago was like after this, to really prevent some sort of a drain of accounts, is to have an authorization for transactions as well. So this is something that they can set up later. So even if a hacker breaks into the account, maybe he can't actually drain the account at that point. But this is, I guess, is for outside discussion.
Okay, I was also thinking, like, from a usability point, we could have that at certain intervals, whenever the user is using the app, he is asked to confirm his password. So this is actually not a security thing. It's more like to ensure that he actually remembers it. And if he has forgotten it, then at this point he still has access to his phone and still has the keys. So at that point we can he can then change the password without any issues.
The password being compromised is a bigger problem than password being forgotten, because in this setup, it's not possible to recover the password, but it's possible to recover the secret without password. All the user needs to do is to go through the legal channel and do it outside of this network to convince the third parties to return the password, the private key.
Okay. All right. Okay.
So we are taking care of. We should be careful the password be compromised, which means the user's private key will be compromised and they lose it. Not that the user would forget their password, because that is a secondary situation which can be solved by a manual process, right?
Yes.
Okay. It's difficult to solve it in the manual process because this guy has to prove he actually set it up, not a imitator. So it's going to be lengthy and non-trivial, but it's possible after all.
Yeah,
that's really good.
Yeah,
that's really good.
That brings up another question then. So I can think of two possible reasons why we want to implement this. One is to protect the user from, because he can't remember the seed phrase.
Yes. Well,
the other is, like you say, to make it. Yes, but if it's for this case, then they have to remember the password anyway. They might write it down, so it's back to the same problem.
Yes, yeah. So you're right.
So I guess the reason for implementing this is more because, like you say, we want to make it more secure, basically because of the two-factor step, right? But then are we supposed to solve the first problem somehow? Is that
What is the first problem?
more
Yes,
important?
the problem.
Where the user
first
can't
problem,
remember the seed phrase.
Yes, the user cannot remember the seed phrase, and the user probably cannot remember a very long password, and we ask them to do a very long password. This is the problem. And the original proposal I had to solve this problem is actually non-cryptographic. So that I asked 3 entities to be legal entities. One can be in China because maybe you need one in China. The other can be in Australia because Boki Puba is the best person. And third can be in Sweden or Switzerland. So the person will individually provide a legal relationship with the 3. So in a sense, like I can get the lawyers write letters to all 3, or I can go through a hold your passport and say I loved certain company, and then do a video, and the other person will authenticate against this person. Therefore, you are able to recover the key without knowing any secret. And this is a dead end, as it turns out that our users is likely to feel uncomfortable with this process after we have done some user research, right? Lucas?
Sorry, it broke up a little bit. Can you just repeat the sentence before?
Okay, so Boon's question is, how do we we are just replacing the burden of keeping the seed phrase with the burden of keeping the password. So can we solve that? And I said that to solve that, we need authentication methods that is not cryptographic. That is, it's based on the users authenticating against 3 parties individually through methods like lawyer's letter or holding a passport and taking a photo. And
or the memorable questions as well, like they have at the bank, you know, like
yes, I propose that too. Yeah.
Who's your favorite childhood actor or something?
Yeah. But user research shows that they feel users feel insecure with password questions. And Lucas, you know that. And what about the passport and stuff?
Yeah. So the password was the most confidence, the one that produced the most confidence for both crypto users and non-crypto users. Questions. Most crypto users would say that they feel that hackers would specifically target this app because of it's easier to social engineer. So they didn't, regardless if it's true or not, they didn't feel secure about the scenario. And non-crypto users, they just would say, well, I hate questions. I would rather just keep on moving on with the optional aspect. And passwords, at least, was the most confidence-inducing. I don't know, like the way I see it here is that we're trying 2 things to protect against the user against a potential hacker, outside party, and we're doing that with, you know, from all the layers from biometric entry to transaction authorization to this wallet backup, and protecting him against himself. And I don't think we fully solved that, I suppose. But so for example, banks use the customer support and KYC, right? If you really lose everything you got, here you don't really have that benefit. So I'm thinking that besides making absolute sure that they know they're accountable for these losses, so far they need to remember their passwords, really. And if they don't, then they might just lose everything.
So there's also the aspect of it here that the password does not need to be that high entropy in this case, because corrupting one of the services does not allow an adversary to brute force it. So this means they can do online throttling to, like, say, you can only try to do recovery 3 times within 24 hours for one account.
Maybe I don't want to fully understand. So I guess at this stage, the problem that I feel we're discussing is protecting the user against himself in case he forgets the password or he repeats the password or it's a really dumb password. Generally speaking, yeah, go ahead. Sorry.
So what I'm saying is that in this case, in order to, it doesn't need to be a super high entropy password. The entropy of the password is not is not essential in this case. I mean, it shouldn't be, you know, just monkey, but it does not have to be like a 12-digit alphanumerical special character password, because in this case, whatever database each of these servers hold will not allow them to brute force a user's password. They all need to interact in order to do that. So you need to have all of them compromised in order to be able to do this. So this means you can implement online throttling of this recovery. So it means that if a user, if you try to recover for a user, you only get, like, say 3 tries to type the password correctly. And if not, then you get blocked for 24 hours or something like that. And you send an email to the user, hey, someone is trying to get into your account. Was this correct or not?
Okay. Yeah, that's because right now I think the only password requirement that I've primed the user to do is 8 characters long plus a number and a character and a symbol.
Yeah.
So I'm not really asking them to do something extreme.
Okay. Yeah. So yeah, it doesn't even need to be that extreme, actually. I mean, it's not that extreme, but this is more. It can be more related to like an OTP. Again, I would not recommend it just being like a 6-digit number. I would recommend it being a bit more, but it's not as critical as, say, like with a recovery phrase or things like that. Exactly because we can do this online throttling to ensure that that it's not that you cannot brute force the password, basically, that you can only do like a few tries, and then we send a mail to the user, and then yeah, you can handle the situation from there on. So it's going to be very unlikely that they guess a password within like 5 or 10 tries, even if it's a pretty low entropy one, unless it's monkey, unless it's like in the top 10 list of most frequently used passwords. But I mean, that is also something we can manually check against.
Okay, I mean, because ultimately, if we're protecting against third parties, it's protecting the funds, not the wallet itself, right? So, I mean, if we really want to reinforce this, I would say that we can think outside of this protocol and put some sort of two-factor authorization for transactions themselves. So the only case would be a scenario where a hacker would physically steal the device and force him to do it. So a physical attack, I suppose. And that would cover it, or no?
Guys, we cannot linger too much on this topic. And this is going to be the last question. So what is this question?
Yeah, I think we drift off a little bit. Boone was talking about what if the user puts the same password as an email? What if he's really dumb and just makes a mistake out of it? What can we do to help him prevent that? To protect him against himself, in case of forgetfulness, I just priming him a lot. If it's against a potential hacker, I guess this solves it. It explains the solution still covers that, from what I understand.
Yeah. So just to Boone, we can protect the user from losing everything as long as they are ready to do KYC. And if the user is not going to do KYC anyway, then it doesn't make sense to provide KYC to protect users from losing anything.
Yes, and Tor also added to that because he mentioned correctly that the password doesn't have to be as high entropy, which helps a lot. So it's a much shorter password than a seed phrase.
It's not the same as if you store the file on Dropbox, which is protected by the password, because in that case, the attacker can simply copy the file down and crack it on his own computer, and it's a lot easier than cracking online service, like we're presenting.
Yes.
Okay.
Yes, so and even if he writes the password, save it to cloud storage is still much better than writing his seed phrase there. So yes.
Yeah. Okay. The cloud is bad because someone working in Dropbox can already take down all the files and start cracking at his home computer. Now, get back to the story. And the same couldn't be done by the parties, by the way, in our protocol. And now get back to the story. Now, let's say a variation of this process is where the second factor is a single security question. Which Lucas proposed that some users accept better than previously, and then the single security question, I would simplify it as two things. First is that the answer to that security question is simply padded after the password and go enter the same protocol. And the second is the security question is simply used in place of mobile phone and email address for the second factor authentication. Suppose we encode a few pre-selected question, or 100 of them. Then the user enter when the recovery starts, the user enter the Ethereum address and provide the password. And then at second stage, the user will be presented with the right question out of the 200s, which all the three servers remember which question it is. And then the user provide answer, and which is actually taken padded against the password, and then the protocol doesn't have to change.
Okay, so I guess you're saying that questions could be included as an optional feature.
Yes, yeah. Internally, it's actually the same as password, but we can present it as a second factor, which is exactly the way you're shown on the user interface, by the way.
Okay. Yeah. Okay. Okay. So it's an option. I think. Yeah.
Yes, and it's better than the user having password without a security question, though, because it gives the length. And so my simplification of the scenario adding the security question at all, can you agree with that? Or do you think? Yeah.
I'm a bit unsure, like because so it depends a bit on how you would do it. Would you have like a separate security question for each of the different servers?
It's going to be the same question. So it's not going to be like you choose three parties and you choose three questions, and question and answers given to three parties separately. It's like a single question, and this is from Lucas' design, and I believe it went through the study. So a single question, single answer, and then the proposed answer simply be part of the password internally.
Okay, I'm not. Don't really see how it adds
security.
Yeah,
it gives length,
but length is not really essential in this case because of the magic circle, basically.
Mm-hmm. Okay.
The length of the entropy of the password doesn't really matter. In this case, you can still only brute force it if you have the database of all the servers.
Okay, so let me explain why I didn't choose the parent solution, where there's a single question and answer, and that answer is sent to all three parties. The reason I didn't do that is because I think it simply didn't mean anything as well, because every party gets the same question. They can, if the hacker takes down one of these servers, they can use this question to make two factors authentication doesn't pointless for others too.
Yeah, exactly.
Yeah. So it's also pointless. But if you say that in the first case it's also pointless, then it's entirely pointless.
There's also the aspect that I mean, a security question is technically the same factor as a password. It's both of them are a knowledge. Of course, I agree that in practice, there's of course low probability that you both end up knowing the password and the answer to the security question.
Okay, in that case, Lucas, do you object that we simply take the security question entirely out of the picture, even just one?
No, I think it's actually the better idea. So the idea is that confidence seems about the same with or without a question for the users. Mm-hmm. And what the feedback was that most would skip if it was optional. So if there's no tangible security benefit and it just complicates things right now, I think it could be skipped. Yeah, and just remove it entirely.
Good. Then take it as a conclusion. Please update the model. So now we enter the second stage, the one variation of this protocol, which is we say we don't take it, and the third one is another variation, which is introducing Google Authenticator as a second factor, and we have done some user research that shows that people seem to be more confident if they have done so. I will demonstrate what happens if you introduce Google Authenticator. So if you introduce Google Authenticator, there is a problem. We cannot adopt the previous protocol because we cannot copy it to the three parties because it doesn't make sense doing so. Because the Google Authenticator secret was it's knowledge, and it should not be shared between three parties. Otherwise, there's no point to have the second factor. So I put this mark here. And there are there are two ways to work to solve this problem. One is to have 3 Google Authenticator code, which is, I think, it's just a stupid idea. Everybody who have 3 authenticator code who enter the process. I didn't even do user research, but I think it's apparent, sorry, unless you want to disprove me, that 3 authenticator code for setting up is stupid. And so that's
difficult, yeah.
That's crossed out, okay? And the second approach is to change this 3-party protocol into this 3-party +1 protocol. So what we do here is when user provide Google Authenticator secret, when we provide Google Authenticator secret to Google, we here refer to Alpha Wallet to the company. And we set up a server, and this server is called a second factor setup tool, okay? And what we do here is we first get user's password and distributedly set up authentication, and then we generate a Google Authenticator code and provide to the user, and it's not shared with any of the nodes, as I explained, because it doesn't make sense. And the user goes enter the secret sharing protocol. During the recovery stage, the user enters the password, and then the user has to enter the authenticator code, which is not provided to any parties, but provided to Alpha Wallet. And then Alpha Wallet signs a permit to every 3 parties, says second authenticator 2FA skipped. Skip permit.
Okay, yep.
Skip permit means that the parties don't need to do a 2-factor because we have done it for them. And then we have the secret sharing protocol returning. So each party will still do a 2-factor authentication, but in the second factor is against Alpha Wallet, not against the Alpha Wallet company, not against the user. So this modification is for the purpose of introducing Google Authenticator as a second factor, because user research showed that users seem to take it as a sign of security.
Yeah, so yeah, exactly. So when I was asking about 2-factor authentication, SMS was quoted as very insecure, and it created this effect that they just considered the entire operation insecure because of this. Email was considered neutral, but specifically crypto users, they were way more confident with using Authenticator app. This was the choice of all of them. But I guess the question here that I have to ask is, if I'm a critic, does this increase liability for Alpha Wallet? Does Alpha Wallet become the single point of failure here?
In this case, Alpha Wallet does become a single point of failure. But you can also argue that because Alpha Wallet provides a mobile wallet, they have some responsibility anyway. And also because Alpha Wallet doesn't know not only the user's private key, but also not any share of the user's private key. Therefore, it can be argued that the responsibility Alpha Wallet taking is acceptable. I'm just thinking.
I don't think it's much increased for Alpha Wallet, the responsibility, given that Alpha Wallet is the one providing the app in the first place.
Yeah.
So, I mean, if Alpha Wallet wanted to be, if you wanted to be evil, you would just extract the password directly from.
There are 2 sides of the responsibility. There are 2 sides of the trust. One side is, can Alpha Wallet compromise user? The answer is no. We don't know any share. So it doesn't adds that kind of responsibility to us at all. And second is Alpha Wallet server becoming now a single point of failure? For example, if Alpha Wallet server is by Amazon, and then Amazon is having a conflict with Alpha Wallet, they shut down the server, then would the user no longer be able to recover their password? The answer is yes. So in the sense of single point of failure, yes, a little bit of responsibility. In the sense of compromising the user, no more responsibility.
Okay. Okay. Yeah. Is there? So I guess the scenario of the user can't recover what they have because of Amazon server issue is not really plausible.
No. Actually, the more realistic scenario is that the party did something to us. But since we all changed our nationality to Australian this year, should be less a problem. So what the party typically would do is they ask you to do certain things, and they can do whatever. There's no regulation what the party cannot do. Yeah. Oh, of course, sorry, I forgot to say the party is Communist Party. I guess everybody knows.
Yeah, figure that out.
Yeah.
Does the two options make a difference when we work with a partner like Buttercard?
That's a good question. That means we are liable if their users cannot recover password too, which is probably, yeah, some responsibility we have to take anyway.
And they might rather that they set up their version, their copy of the verifier.
Yeah, they might, but honestly, I don't think these people want to.
But given an option, I wonder if they will want their customers to be able to recover their wallets more easily, because it could be a support problem for them if users lose access. Of course, we can just say that we can't offer this to them. That's one way to answer them.
Yeah, so I imagine in certain cases, a fork of our wallet will want to run their own verifier. Yes, and if someone compromised this Alpha wallet, this Tor, do you think in this setup a hacker has more incentive to try to compromise Alpha wallet? This server, I use this yellow thing, sorry, orange thing. It's called Amazon Lambda symbol. So do you think that with this setup, the hacker has more incentive to crack this than compared with the previous setup?
Yeah, because then that's the setup that holds the second factor. So if the adversary already has an idea of what the user's password is, then Alpha Wallet will be the one in focus, because it can still not succeed unless it has the second factor.
Okay, so coming back to Lucas, this means also we will become honeypot. Yeah.
Okay.
So and arguably, us becoming honeypot means lowered security, actually, because now they have only one to crack instead of cracking 3.
Yeah.
I mean, that's only on the assumption they know a user's password.
Yeah. Well, they probably will attempt anyway, assuming that 3 tries a day will give them some users' password if they try enough users.
Ideally, there should also be some throttling on IP.
Oh yeah.
So I mean, still, if you have like a botnet with an IoT based botnet, of course you can like try quite a few.
Would you agree with me, Tor, that in this setup, having Google Authenticator is still more secure for the users who don't want to give their mobile phone SMS anyway?
Yeah, definitely. It adds more security, definitely, than not. Yeah.
Yeah. So then it kind of makes sense.
Yeah.
Yeah.
I would also suggest that in this case that users only learn if the password was correct after they add the 2-factor authentication.
Oh, so this case is the reverse. Yeah. So the previous case, user validate the password first and then do the second factor second, because we don't want users to be bombarded by attempts to guess the user's password. Receiving SMS midnight every time when somebody tries to guess your password. But with 2-factor, the order is reversed. So I should change the order. Thank you very much. That's a really good suggestion.
I think actually also like in the other, that would also be the ideal to have it reversed, exactly because we might not have high entropy password, and this will prevent anyone from even checking.
But is it possible that we don't tell the user if their password is correct. We simply ask them to enter the second stage, and if the password is not correct, we simply don't send emails out.
Yeah, that's true. You can also do that.
Yeah. Okay, so if we do that, then we can protect the user from bombarded by the password attempts.
Yeah.
Okay. Okay, so it doesn't change the order, right? Two-factor.
No, we do change the order for Google Authenticator, but we don't change the order for SMS and the mobile phone number.
But I mean, I guess it doesn't add that much. I guess it adds more motivation. Like if the server tries it, then at some point finds out that it guessed some password, they have more motivation to compromise some specific second factors. Whereas in the other case, they're shooting a bit more in the dark by not knowing whether they've guessed correctly. I mean, they still need to compromise both, but in the case where they learn whether the password was right or not, they have more of a motivation. Which, I mean, in case of Alpha Wallet, I mean, it will be global. I mean, you would, no matter which user, you would need to compromise Alpha Wallet to get the second factor. Whereas if you use email, then it means you figure out which email you actually need to compromise to get in. So yeah.
So we can be. This gives us advantage of sending the email and clearly say that if you have not initialized the password recovery, the security recovery, then somebody already know your password.
Yeah, exactly.
Which means the user can change immediately. Which early notification is important. You know, coronavirus.
Yeah.
So yeah.
Change immediately.
Okay. So the modified protocol is this order. Okay. Yeah.
Okay. Terrific. Okay. I guess I just wanted to ask, just to clarify. So, two-factor authentication is still more secure than, for example, if I just remove the two-factor and the using Authenticator app is still more secure than if I just removed it and we used it only the email as the two-factor.
No, I would say like with this flow, I would say the email approach is the most secure one, especially because in this setting you also protect against. I mean, you protect against one of the servers being malicious, since you need to get the second factors from.
Yeah, it's counterintuitive. Typically, people say Google Authenticator is more secure than email, but because of the protocol we're designing, it's not more secure. But if the people would choose not to provide as a mobile phone and email, then for these users, Authenticator is more secure than simply choosing no two-factor at all.
Okay. Okay.
It makes sense to you, Tor?
Yes.
And if you anticipate a lot of users will simply not use email as an SMS, then we will enter we will save them by the Google Authenticator. Or because of the complexity, you guys know that I want to reduce the complexity of the project in order to deliver it. We may choose to implement a Google Authenticator second stage. So those who would not give anything, they would not give their mobile phone number or email address. These people we will simply let them know that they have to use seed phrase, and we will save them in the next year.
So there's also the issue with using Google Authenticator and phone in this case, that what we are generally trying to protect against is a user losing his phone where he has his private key on. Because in that case, a user might also lose his phone number. I mean, he might be able to recover it on a new SIM card, but he might also lose his Google Authenticator unless he also has it on a different device, like a secondary phone or an iPad or something like that. But I'm not sure everyone does that.
So Lucas, I think the way you look at this is the cart abandonment, right?
Mm.
So if whether or not user would happily finalize the process. So cart abandonment referred to you just started the process, but you didn't check out because you are concerned.
Yeah, I'm just trying to understand what you mean, because okay, so I understand the concept that if, it's true, if the user loses the device, they need to have some sort of master code to get their authenticator back. This is not a solved problem yet, at least in the user perspective. Can I think a little bit about this one?
Yeah, can you just to help you to think, the advantage of having Google Authenticator is that it's more secure than those who refuse to provide. It's more secure for those who refuse to provide email and mobile phone number. And the disadvantage of having Google Authenticator is that the software is more complicated. Alpha Wallet becomes a honeypot, and the user probably are not protected anyway because they probably lose the Google Authenticator together with the mobile phone.
SMS. Okay. Cons. Honeypot. Okay. Yeah.
So advantage, it's more secure for those who don't provide email address, but for those who provide email address is more secure. And
right.
yeah.
I mean, yeah. I mean, at that stage, start to make me consider if the step number 2, which is the setting up the two-factor authentication, the only option becomes only email instead of
SMS.
mail. Again,
oh, people don't like that.
SMS has the same issue that, well, I mean, it's easier to recover a phone number, but than an authenticator, I would say. But
I don't know. So yeah, like most crypto users, they were very against SMS. They were very vocal, like this is just doesn't feel secure. There's a lot of stream swap attacks. Spoofing is easy.
Yeah, definitely. It's also less secure. That's also the other thing. So SMS is not highly desirable. Although with an SMS, you don't have the issue that the same password is used here and in the user's email account.
Yeah. Lucas specifically faced the problem of how to let the users finish the process confidently.
Yep. Yeah, it was about confidence, a lot of this question in particular. And SMS, again, for the crypto users, just didn't strike them as secure. But for non-crypto users, they were fine with it. I mean, banks do it, but I think the fundamental difference is banks ultimately, they have insurance and they have customer support to bring you back if anything really goes wrong. Here, we don't have that benefit. So the confidence of SMS just seems to be, the trade-off doesn't seem to be worth it at that point. Mm-hmm. But email, they were more neutral about it.
Mm-hmm. Yeah. So at least we can agree password security question is gone. Unless you make a lot of them, it doesn't add security. But if you make a lot of them, it's mess. So it's also not good for the recovery. So there's dead end for that. So we simply remove that.
Okay. So I guess the question right now from that kind of lingers in my head is
how important it is.
Yes. So email only or email and authenticator app as a sort of a second option, because it does increase confidence, but it does seem to be less secure, but not insecure anyway. Mm-hmm. Okay. Yeah.
Again, with the Authenticator app, there's also the reliability issue that now we have another party which always must be online.
Availability issue, yeah. When Alpha Wallet node is done, people cannot recover their process. The availability issue is a concern for the existing secret sharing protocol too. Even if one node can be allowed to fail, the chance of two failing is still possible because we're in early stage of blockchain and everybody play with their ideas and never care about availability. It's just a culture.
Is it also possible that not every target user has an authenticator app or know what it is? Does it matter?
Yeah, I'll say a lot of users will just speak email, specifically non-crypto users or less security-minded users. They will just go with the simplest option. Is that what you mean?
Yes, like if we provide that option, they might not even know what is an authenticator app for some users.
Yeah, I would say so. At least in the mobile phone itself, setting up the authenticator app is a bit more annoying than in the web, in the desktop. It really was an aspect of confidence. Crypto users liked the authenticator. They chose it specifically for that. But they were also a lot of times comparing it to the fact that the other options were email, SMS, and using Google Connect or Apple Connect. So perhaps it tends to just asking a few more times, and just removing it and asking, and just showing email and then seeing if the confidence remains. So maybe I should just check, because right now I guess there's a bit of a trade-off, I suppose. Maybe there's no confidence loss, and they're not fixated on the authenticator if they're never shown that, but they're also not shown the SMS. They're only shown the email as a two-factor. Then it becomes like, that's just the one choice. They never think about it. Does that make sense?
FYI, I have to leave for another meeting in 5 minutes, but I can join
please,
again.
actually, efficient topic, actually, mostly. There also all of that left is homework for Lucas to know, because we have done the mapping of the technical landscape.
Yeah, this was great. Yeah, and it helped a lot.
Okay, good. So so far so good, and we please stay in the meeting room to start drinking. And if you guys have beer with you, yeah.
Got some wine.
I will join with a second device that has a camera. So I will leave now and come back. You guys can use this time to find your beer. Okay. Okay. See you in a bit.
Okay, thanks.
Thanks.
Right, thank you guys. See you later.
Thanks.
Thanks, Tor.
Although I knew that Ray would bring in the whole the party talk, like all this talk of parties. It was inevitable.
Yeah.
Okay. I have to go and get my beer. So what beer do other people have?
I don't even know if I have anything. Check. I think I have wine.
Yeah. Okay. Well, that's all right, I suppose. How about you, Sunil? You're on mute, by the way. Oh, Mountain Goat. Nice. Okay, that's good. I like that one. Hang on. Oh, there.
I only have ginger beer.
Ginger beer? Is it alcoholic ginger beer?
No.
Oh. Hang on. I've got to go and get a top up.